Okay. A mobile phone requires 11 volts. The mains provides 220. The number of turns in the secondary is 22. How many turns are on the primary? So V1 over V2 equals N1 over N2. Do you have an answer for this? 440? Yeah. Man, I am hungry. Where is Kim with those Brevita biscuits? That would be good right now. Any of you got any Brevita biscuits? No. No? Matt? Any breakfast biscuits? Oh, we need Kim. Where is she, by the way? Was she in class yesterday?
Yeah.
The morning class?
Yeah,
or
she was in class.
Yeah, okay.
Because yesterday we ended early, so.
Yes, okay. I think Siba has an appointment and Chow asleep, perhaps. Huh?
It is Siba's birthday today.
Is it?
Yeah.
Really? That's not what she said in the email to me. How old is she? 19? 20. So if she watches this video later, yeah. We think 20? We'll draw her a cake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I know she never wears a dress, but it's the only way I can draw her. Okay. Number 2. An electric car requires 1,100 volts and the mains provides 220. The number of turns on the primary is 110. What is the current in the secondary if the mains provides 13? Okay, so we have the formula V1 over V2 equals N1 over N2. You also have the formula that I2 over I1 equals N1 over N2. Do we know anything else? Oh, we know that the number of turns on the primary coil is 110. So that's 110. And what do we want?
That's I2 over I1.
Yeah, it's actually upside down, the formula. It's I2 over I1. Yeah, it's opposite. You need to be careful with that in the exam. What do I ask you for? What is the I2? Right, so first we have to get N2. So N2 will be 110 times 1100 over 220. And then you can sub that in here for N2. So you can get I2 is 110 times 13 over N2, which is 110 times 1100 over 220. So they cancel. So it's 13 times 220 over 1100. Right, so what's that when you're ready? 2.6 amps? No, it should be smaller than that. No. Well, maybe you're right. 2.6 sounds good to me. Yeah? Can I continue? Okay, number 3. So, do you see the picture number 3? I don't know if you've ever seen those before. If you're traveling around the city, you sometimes see these small substations, they're called. They take the voltage from the power cables and they reduce it. So the big electrical cables, they use a voltage of 10,000 volts. And then when it comes into the city, the voltage gets stepped down. So the V1 is 10,000. And the V2 is 200. And the primary coil turn-ins is 1000. We don't know N2. What is the current of the high voltage? So I2 we know is 13, I1 we don't know. That's equal to N1, which is 1000, over N2, which we don't know. So it's similar to the last question. We have to get N2 first. Let's see, cancel, 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 cancel. 1 over 20. So N2 is 20. So that's actually a 20. Cancel, cancel. So that's a 500. So the I1 is 500 over 13. What's that, please? I made a mistake. That's not right. Let's double check. V1 over V2 equals N1 over N2. Is N2 20? 100 divided by 2 is 50. Thank you, Matt. Not 500. So that's 50 over 13. So what's that? 3.85 amps. Oh my goodness, I'm so hungry. Continue. 4. A transformer with 100 turns in the primary, 10 in the secondary is 90% efficient. The primary supply is 220. What is the current in the secondary if there's 1 amp of current in the primary? Let me just draw this to make this a little bit clearer. So what you have going in is you have 1 amp at 220 volts. It goes into the transformer and it comes out at a different current, we'll call it I, and the voltage, we could work it out. So the voltage, it goes from 100 turns to 10 turns. So that's 100 over 10 equals 220 over the voltage we want here. So I think this will be 22 volts. Now, you might be wondering, or maybe you're not wondering, when the transformer is 90% efficient, it means something is lost. And you might say, well, why is it the current that's lost and not the voltage? You know, because you have your formula power equals IV. So if it's 90% efficient, it means one of these two is going to be 10% less. So that you get 10% less power, okay? Like at the beginning, what's the power? 1 times 220 is 220 watts. At the end, it's 90% efficient. So you don't get 220 watts coming out. You get whatever 90% of 220 is. What's that? 198 watts. So one of these guys has to be less than it should be. I usually imagine the current being less because when you make a transformer, the job of the transformer is to change the voltage. So if I have a transformer that's supposed to reduce the voltage from 220 to 22, I imagine it's the current that was sacrificed. So anyways, let's get the current now. The current is P over V, which is going to be 190 over 22. What's that? So 198 over 22. Hmm? Exact?
Yeah.
So think about this. The voltage was 10 times smaller when it came out of the transformer. Yes? If it was 100% efficient, then the current should be 10 times bigger to compensate. But here it's only 9 times bigger because it's 90% efficient. Okay. Right, the last one, number 5. In the picture below, find the current in each part of the process. Note that the final current is 13 amps. Okay, so if we go backwards, we start off with 240 volts, and then previous to that was 13,000 volts, and then previous to that was 400,000 volts, and then previous to that was 12,000 volts. And in this picture here, you get 13 amps. So look, I'll give you the quick way of doing this. The voltage is bigger here, correct? If it's 100% efficient, then what should happen to the current? Should it be bigger or smaller? What do you think? So the voltage became bigger. What do you think happened to the current? Smaller. In fact, it's proportional. So the quickest way to do this is just to multiply by 240 over 13,000. So what do you get here? 13 times 240 over 13,000.
Zero.
0.24 amps. And then the same thing happens again here. It's 0.24 times 13,000 over 400,000, which is the same thing as just 13 over 400. So what do you get for the next stage? Smaller again. Got an answer, Matt?
7.8 times 10 to the 9th street.
So yeah. 0.78 you said?
Yeah. No, 7.8 to 10 street.
Yeah, so sorry, yeah, 7.8 milliamps. And then for the last one, the voltage is getting smaller, so the current gets bigger. So your last answer multiplied by 400 over 12. So the answer you have on your calculator, and multiply that by 400 over 12, please.
0.26.
0.26 amps.
Yeah.
Do you notice how this answer is quite similar to this answer? Well, that's because the voltages are quite similar at that step. Okay, let's see. Yeah, great. We'll go on to the next lesson now that we've done 3 tutorials.